Turns out that a conditional statement is logically equivalent to a disjunction in symbols, saying that P implies Q is the same thing as saying not P or Q. And how can we do this? How can we show this? For now, we can show this using a truth table. So try to design your truth table to show that the statement P implies Q is equivalent logically to not P or Q. So again, we need 4 rows because of the letters P, Q. And again, there's letters P, Q. Once you have decided how many rows there are, figure out what columns you have to have in the table. We will definitely need a column for P implies Q. We also need a column for not P because it has higher priority than the OR. And we need a column for not P or Q. So the total is going to be 3 extra columns plus the P and Q columns. And we again start with P being true then true, false then false, and alternate again between trues and false for Q. Next, for the column P implies Q, we look true implies true, this is true. True implies false, this is false. Finally, the last 2 rows are true by default. That's why we have 2 truths right there. Now the column for not P, we just need to look at the column of P and negate that whole column. And that's where we get these truth values from. Finally, we need to look at the column of not P with the column of Q. So looking at the column of not P and the column of not Q with the disjunction perspective, true or false is going to be true, and so on and so forth. You'll notice that columns number 3 and columns number 5 are containing the same truth values. For instance, the column P or Q has true, false, true, true, and the column of not P or Q has true, false, true, and true again. They're identical. So therefore, this implies that the conditional is logically equivalent to the disjunction not P or Q.